Hello, everybody. Welcome to this COBOL Compute Shift Measuring the Impact webinar. My name is Jorge Morlet. I'm the Field Sales Director here with CloudFrame. So let me start by first telling you that this is not a standalone webinar. This is a series of webinars. And so if you've been on this series, you will be already by this time familiar with our products, familiar with our terminology, and maybe even my accent. So let's go a little bit backwards and review what we've been talking about in the past. In the last session, we talked a little bit about shifting the COBOL compute, how the process is done, and what are the benefits that you get from moving your compute from COBOL program to another platform. And one of the main reasons it's cost, but we also talked about many others and how the process can be done and how you can do this without risk or minimizing the risk and controlling also the impact of that change. So this is a thing that we analyzed on the last webinar. We also talk about the top reasons that we've seen in the market of customers doing that shifting process. Okay, so reduce the costs of the present costs that they have in order to avoid future costs. That's a thing. This is we know that most of the customers, they have yearly increasing costs on, and the invoicing is going bigger over the time, despite that there are many licensing models and even ways to acquire or lease the hardware. The result is that most of the customers, they're getting more consumption, and so they need to increase, or they're seeing that reflected in their invoicing. Okay, so that's one of the reasons. Also, to optimize the use of some resources. Most of the mainframes, I think that from series C13 and up, they have some specialty CPUs, particularly zIIP CPUs, or some other customers, they may already have some deals with new vendors related to the utilization of cloud capacity. So shifting your COBOL to a Java platform that will allow you to utilize these resources to its best, optimize utilization of that. So you will allow your resources to actual resources, and now I'm talking about people, not only hardware and software. So these people, they will be able to focus on creating new functionality and add value to the business directly. Okay, this will allow you also to improve your operations in the long run. Okay, another important thing is to ensure the SLA achievements. By shifting your COBOL compute, you can decouple the heavy, not so critical operations to and shift that to another technology, and this will allow you to ensure your SLAs to the critical parts of your operations, and that's very important, right? Also reduce the risk while you're retaining the business logic. That's very important. So you stay off of problems like obsolescence or not supported softwares or things like that. Okay, but most importantly, you don't want to go over the peak, because like I mentioned, some customers, they will be heavily impacted in their invoicing if they go over the capacity that they have contracted, right? Then here is a little bit of the entire series of webinars that we've been doing. If you scan this QR code, you will get direct access to these webinars. In some of them, we've been talking about, building your case for shifting the COBOL compute, explaining deeper how to use and how to optimize the utilization of your zIIP CPUs to reduce costs. We've done live transformations. This is an entire series that will get you to take you to the knowledge and understanding on how to really do some very well controlled, at your pace, mainframe modernization. Okay, and during these webinars, we've been talking deeply about our products, specifically about Relocate. And I use very frequently this single slide to explain what relocate is and how powerful it is, and what are the main differentiators in the market. Because relocate is unique in the market. This is the only solution that will allow you, with the minimum impact, keep control on how do you want to migrate your compute or your workloads to your zIIP CPUs, USS, or any other cloud platform. Okay, it is very fast to implement. It is very low risk because you can take control at the very granular level. And I'm saying in one JCL or in a specific JCL, you can choose one specific step, and then that COBOL program that is running on that step is the one that you want to relocate, the one that you want to shift to your zIIP CPUs. You can do that at that specific level. Not only that, as you are cross-compiling, it is also the capacity or the possibility that you keep developing in COBOL. So you don't have any disruption or impact to your organization because you can keep developing in COBOL. And every time you deploy this COBOL, it is automatically catched by whatever solution you may have already in your software development lifecycle. We catch that. We do the cross compilation automatically because this is all automated. And then as you start testing and you're going through this SLDC, what you will see is you're working already with Java, and this is completely transparent to the organization. Okay, we call this the backward compatibility at the COBOL programming level, but we also have backward compatibility at the data level. So one important thing to mention is we have a runtime CloudFrame started task, which is listening for these calls that are coming from the mainframe. So when you get to the step into the JCL, you call the Java program. The Java program gets executed, and it gives the return, the control back to the mainframe COS. And that runtime will manage all the relationships and whatever is needed to do the readings and writings in the data. We can do that with BSAM, QSAM files. We can do that with sequential files and DB2 accesses as well. Okay, so that is the commercial part of the process and of the webinar. So you know exactly what relocate is if you've not been in the previous sessions. How does it work? I think I described the process on the design time. We basically can help doing the migration process completely automated. The customer can decide from a single COBOL module to an entire chain of calls, entire JCL, all of the COBOL programs on the JCL, a mesh of JCLs, or an entire application. It's up to you to decide what is the pace you want to follow here. And so we automate the migration process, and then all the code that is cross-compiled is going to be stored in the USS side, in the file system of the USS, and it's going to be ready to receive the execution instruction from the mainframe. So once this is executed, you during a test, you can basically execute on both environments and then compare the results. And I'll talk a little bit about this later as we're doing the test process, because this is exactly how this should be done. Now, the objective of this specific webinar is to help you really measure what is the impact of shifting your COBOL, and how do you can tell that if you succeeded or you did not. Okay, the most important thing as you're starting a project like this is to set the correct expectations. Know exactly where are you headed to, where do you want to get, right? If you don't know where you want to get, well, you're stranded, right? So I think it's important also to say that when you are about to shift or start a shifting project, you need to know what is your sources criteria, okay? And also make sure you have a proper baseline, because also you need to know where it's just that you're starting and where is that you want to go. I'd say set your proper baseline. It's the starting point and the success criteria is where you want to get. What is that you're gonna go? Okay, and it is very clear here. If you don't know where to start, you don't know where to go, right? So this is very important. We will give you some hints on how to establish that success criteria just in the it's a few slides from here. But we're also going to help you to understand how to set that proper baseline, because it is very important part of the process. Now, in previous sessions, we also talked a little bit about the solid business case, and this is very important because most of the decisions that these big organizations they do are related to money, right? In the end, we are all working in a business, and we're trying to get the best out of the economic impact of this, right? So, to plan a solid business case, we can help you. We've been helping customers with different tools and solutions that we've been working with. And I'm going to swap just for a second to this landing page that I have here. And I don't know, I can move. This is our business case calculator, which is meant to work for customers that they are thinking on making the decision process or no. It is a very simple calculator that you input information from 6 different questions. And once you input that, you will get a number. The calculator will tell you an estimated number. And I'll talk a little later about the accuracy of this business case calculator. And with that number, you should be good to decide if you want to start your Shift Compute project, right? But how this business case can impact, or what is that you want to really be careful with? Well, first, you need to set a strategic context, okay? It's where am I and where do I want to go? And this goes together with this previous point. Where am I right now? Where is my baseline? And where do I want to go? What is my success criteria? Okay? Then do an economic analysis. And I just talked about the calculator. That is going to help you a lot. When you run the calculator, also go and do some other analysis, which is what will happen if I do nothing? What will happen if I do a manual shifting of my compute? And what will happen if I do an automated shifting of my compute? And compare the 3 scenarios and make sure that you are ready to, support this and take it to the next level. Think about the obstacles that you may be facing or will face during the process, like a lack of resources. And I'm talking about people. I'm talking about the compute power itself. I'm talking about economic resources. Lack of time. If you don't have time to do this, you cannot start a project, right? And maybe also lack of interest. Maybe your decision makers, they have other things in mind, that there's bigger projects in the organizations, maybe a fusion, maybe something like that. Maybe this is not the right moment to start a project to reduce costs. But who knows, right? Or also take a deep understanding, what is your strategic goal? Is there a compelling event moving you or pushing you to do this shifting compute project? And what is that? You want to get more market share? You're going to reduce costs? There's got to be a trigger that will help you take these to the next level, okay? And the risks. Make sure that you measure and take care of the risks, like the operational impact and the business impact, okay? And take a look on the overall big picture. The U.S. market, they've been talking about the recession. There's like negative and positive, indicators. So some of the customers that we've seen in the mainframe space continuously, they are in the financial market, so they surely have way better information than many others on this, to take a look on the big picture and then make a decision, right? So these are the 6 main elements that we consider that should be looked into very detailed, so to make a decision if you want to go and move forward with your shifting compute project, okay? Now, I promised you that I was going to talk a little bit deeper on the success criteria. And one thing that I've seen on, well, I've been on many, mainframe modernization projects, and one thing that I've continuously seen is that if you have to keep this simple, okay, you have to keep this as a very easy to measure metrics, okay, and try to stay on the safe side of the hard numbers, okay. If you get hard dollars, if you get clear indicators and nothing that is subjective, you are gonna have better arguments to make a better decision, right? So your decision process is gonna be better supported. So I'd say it's very simple and easy to get the functional equivalency, which is this is the baseline was running, giving this input, giving us that output. I want to get the same as I shift my compute and I cross compile. I want to look exact the same results. Okay, and that's very clear. That's a clear indicator. So I want to reduce my MSUs. I want to, maybe define some elapsed time criteria, because even though these particular processes that I'm going to shift out of the mainframe or out of the central processors, they may not necessarily be critical. They should also have a limit on the elapsed time that they will consume. So I gotta know those limits, and I gotta tell if I go over this limit, this is not, within my success criteria. Okay, and also make sure that you know what is the capacity that you have on your zIIP CPUs. Some customers, they don't even know that they're already using the zIIP CPUs. DB2 nowadays is consuming zIIP CPUs, for example, up to 60% of those transactions without customers actually doing nothing. So just make sure that you are not going to overload your resources in that other side, right? Now, how to capture the baseline? This is key also to make sure that we're gonna have accurate starting point. Okay, I actually opened in advance this link, which is to an article that we get from Mr. Craig Mullins, talking about the understanding the mainframe pricing to aid the modernization and cost control. This is a very nice, short, but very clear article that explains you what do you need to do to find, and to really know what is the impact that you're going to get in the cost as you do some improvements, right? So here, Mr. Mullins is telling us the first thing you need to do is use what you have in your hands to make the decisions. And he's telling us, go to your subcapacity reporting tool, and in that subcapacity reporting tool, find the SMF records 70, 89.1, 89.2, and then make sure that you get those reports and start making some analysis. And he's even, showing to us some parts of the report, the P5 section of the report, and then he's telling, well, as conclusion of what I see here, this is where the peaks are actually reached, and this is where the customer should focus on doing some reduction of costs. If they get to reduce the utilization at 6 a.m. of some of these resources, they probably will get a very good impact in their invoicing. And this is just an example. There's an ebook that explains this in further detail, but most importantly, we can offer to you helping with the process of this decision making, because we know that there's many types of invoicing models, and everything is going to be different depending on that. Okay. Once you are able to see this and you know where to put the finger on, one thing that we can also help you do is to go into the production logs, find the JS outputs of those jobs, and then determine which jobs to work with for this test. Okay. Basically, we're just going to focus on the major consumer in the step number 2, finding the major consumers, and then let know which are the programs that are consuming that time within the jobs. Then on step number 3 is finding the good candidate applications. Okay. In the previous session, I talked about in full detail or in some good detail about what is the good candidate applications. Basically, we're looking for sequential file accesses or cursor DB2 accesses. Why? Because these are the ones that out of the box using Java techniques are going to give us the best. Okay, not saying that others will not do also very good performance. We can work with that together with you, but these are the ones that we mentioned already in the past, and those are the ones that we've seen getting the best results. Okay. Then identify your critical volume measures, like I already mentioned about the batch window. How big is your batch windows, and what are the criticality of the processes that you want to get into those windows. Also, what are the number of records that you typically manage in a day end, or in a month end, or in a year end? And then the number of transactions that you are continuously receiving by hour or something like that. So those volumes are important for you to be able to project, because if you're going to do a test, highly likely you're not going to do with the production volumes, or and then you can project that. Also think that some customers, they tend to forget is the seasonal impact. Like year end, some customers, they have increase in sales. Some others, they have a potentially summer more demand, or that kind of things, or even peak hours. So this is a thing that needs to be taken in consideration in order for you to decide what is going to be the modules that you're going to test with, and where are they, and where do you want to get with those modules, and without shifting your compute. Okay. Now, to execute the shifting itself, we are showing you a process using the relocate solution that we have. Okay. The process is very simple. In step number 1, you run your JCL consuming the COBOL as is. Then step number 2, you automate the cross compile. Step number 3, you run as Java. And step number 4, you compare the results, the as is against the course compiled on Java, and then you test for the variations, because you need to compare apples to apples. What was I producing before? What am I producing right now? Is this satisfactory results? Is there a margin of error, like for example timestamps, or not? That's the variations that we need to analyze in deep. Okay. Most of our customers, they are using solutions that they come out of the box in the mainframe, like a Super C IBM utility, the supercomputer, that will allow you to check what are the difference between the baseline and the newly generated output, right? It's not Murphy's law, but it can happen that there's going to be some differences. I created this report yesterday and enforcing a difference in between the files that we had as input as output. Typically, this is my demo, and I don't get any differences, but I created this one on purpose for you to see that this is the way you can get those reports, and this is how you can find exactly where is the difference. Okay, so find the differences. Then I already mentioned relocate is fully automated. So once we find the differences, we fix the product and we provide you a new version. You remigrate the same module, and then you re-execute the test until you make sure you don't have any differences. Okay. How frequently that happen? Well, it's going to happen less frequently every time, because relocate is a pattern recognition, artificial intelligence based solution. So every time we find the difference, we don't fix the difference. We fix the part of the auto generation that will avoid that difference from happening again. Okay, so you will never see that difference again. And the more you do this, the less problems you're going to have. We already have in production many customers. The last 2 POCs that I've done, it was practically zero differences. Okay. And then after you run the test, you don't have any differences, then you have to go back to the numbers, right? What is happening? What were the results? This is something that is real numbers out of one of the latest POCs that I've run with a customer. And I have some important notes to say about this analysis. First, how simple it is. And like I said, try to keep it very simple. If you go into full detail, the margins of error could be very small, and you will maybe lose a lot of time and waste time for you, your people, and maybe not necessary to go into that much detail, right? Second important thing to mention, it's we are out of the box doing the application of a conversion process that injects modern Java techniques. So the cross compile is not just convert this if to another if, or convert this while to, or this for to a while. That is not what we do. We do apply new Java techniques to our code, and we apply things like the prefetching, like serialization. We eliminate dead code, and we do things like we converted global variables to local variables, and lately we're even working on a JDBC proprietary adapter that will help us to improve further the performance. Now you may notice, and let me explain a little bit what's those numbers on the right, on the top right. The execution with COBOL consumed 4.8 seconds of GPPs, and it took 21, almost 22 seconds for the entire execution on the elapsed time. In the Java, we consume practically zero central processors, but then we consume 34.5 seconds on the Java zIIP CPUs, and the elapsed time went almost to the double. Okay. Like I mentioned, this is a number that we got out of the box without changing or doing any type of performance improvement. Okay. We know that we can do further performance improvement by applying what we call the performance guidelines. These guidelines will help the customer work on the best ways to configure the solution, like files allocation, optimizing buffering, or even work with some DB2 parameters that will improve further this process. But even though this could be deep in a deeper level, still optimized, like using DB2 trace, that will give you a lot of information on how to improve that. We're also providing to the customers with a solution that is a CloudFrame trace agent that will let you know exactly which of the methods was the major consumer of CPU and time. And that is going to help you a lot to make the decision on where exactly go into and do the tuning, and that is going to save you a lot of time. Now, these numbers that you see on the Java zIIP and the elapsed, they typically are not shown in the JS outputs. It's a configuration thing that you can do, but we are giving the customers these numbers out of the box, so they don't have to dig into the SMF records. And these reports are going to make it even easier to gather. Okay. We know that there's many, licensing models. Some based on the running 4-hour average, some others the newest on tailored fit pricing, some others based on the running 4-hour average in peak or normalized every hour. We know that this could vary. And this particular customer, they had a very unique model in which they are being charging yearly for the zIIP CPUs, which is very infrequent. And that new thing created some extra cost that it was not considered originally on the business calculator, and that gave us a deviation. And that deviation, it was 5% because the calculator at the beginning gave us 74%. So that's going to give a 5% deviation that we got. And the reason why is because we didn't know about this little Java issue, right? Because once you have these numbers, it's very easy to get and justify your business case. Okay, so you just very simple math, you multiply the price of your unit of measure for the GPPs by the consumption, same thing with the Java GPPs and the zIIP GPPs, you get to a number. Now, I know a lot of people can tell, well, that number can vary. Yes, it can vary a little bit depending on different circumstances. What we did is we executed several times during peak hours and during not peak hours, this specific test, just to make sure that we were really getting an average of the execution. Okay, then we just did a simple math. We keep on the hard numbers. Okay, and then if you want to know exactly how much this 68% reduction on the cost of the execution of this process will impact your licensing model on your final invoice, we can help you with that as well. Okay, and that's how you keep safe on the on knowing good numbers, hard numbers, and very low margin of error. Okay, and like I mentioned, yes, we found something here, 5% the differences, because there was something that we never seen before with this particular customer. Okay, and those variances are the ones that you're after. You're trying to find these little details that are going to get you to the best possible accuracy on your projections. Now, let me summarize a little bit all that we've been seeing about the impact of shifting your COBOL compute. This is reduced to basically two types of impact, the economical impact and the operational impact. Okay. It is very important that you focus on reducing your CPs, your central processors utilization, but also make sure that this is going to positively impact in your invoicing. Either rolling 4-hour average, your MLC has to be lowered directly or indirectly, depending on the type of contract that you have. But we need to make sure that you can justify the short and long-term modernization and the utilization of your resources to the best possible level. And I already talked about the underutilized resources. The zIIP CPUs, particularly in this case, are very important. And with this and the information that you generated in the previous example, in this exercise, you will be able to go back to your business case calculator and get more precise numbers. Okay, and with this, you can justify your economic impact and eventually get budget to roll this out and start getting bigger savings. Okay, so that's how you can reduce the or control the economic impact that you will get as you're doing your shifting compute. Now, what is the impact in the operational? Okay, well, I already mentioned, make sure that first you get the functional equivalency. Okay, make sure that you don't have any disruption to your COBOL processes. Your software development lifecycle should keep the same, should remain the same. All of the changes that you need to do, they should be based on automation. Okay, and obviously automation, I mentioned already, can work with your whatever solution you have, like a Changeman, Endeavor, ISPW. We can help with that. The no risk, it is very important, or the low risk is very important. I already mentioned as well, you can start from one single module within a JCL only, and you can go as big as you want. The risk is also low because you have a very easy rollback process. in the step in which you want to execute as Java, you only need to change the load libraries, and that is going to execute as Java. If you have any problems with that, you can roll back by just shifting back to the original libraries, and then you execute as COBOL. So it's a very simple change that will help you to control the risk. Okay, it's a very easy and secure rollback. And this is how you can start your incremental modernization journey. This is how we see the process. This is how we can help you to control the impact of this type of modernization. Okay. Let me just talk a little bit about success stories that we've seen, customers that they already are utilizing relocating production, like this oil and gas company. They basically were able to use the relocate solution to reduce the MIPS utilization by 47%. And they were able to cross-compile, automate the process, automate also the testing that they already had and making sure that they don't have any differences. They projected the margin of cost reductions. They justified the project, and they actually rolled out this, and they are already getting this 47%. Now, one important thing is you'd say, but what type of applications is this working with very good volume and the response time is good enough? Yes, it is. This I was talking about the batch windows, but this customer in particular, they are working with the energy futures trading application, which is very or highly time sensitive, response time sensitive, and it's working very well. And that 47%, it is a big number, believe me. Okay. Another customer, which is work in progress, a large financial bank institution. And the numbers that you saw are actually here. And that 70% is the one that we showed to you without doing any fine tuning to that application. But we know for sure that we can get a little bit over 70% on that application in particular. This is a much more batch-oriented process, but as you can see, the margin of gain, it's even bigger. So it's a by-case scenario. And like I said, we'll be more than glad to help you going through this journey. David?
I think we've done a good job of covering everything there, George. I thank you for taking us through that. We clipped through it pretty quickly. You had a couple of questions that come through around just chargeback and how organizations are dealing with that and reporting back on it today. But I think we can jump right into some of the frequently asked questions. Obviously, since this is a solution that's pointed at reducing cost, people are interested in what average savings are. Do we have any type of framework for what we see as far as the average MIPS or MSU reduction for customers that implement relocate?
Yes, and I'd like to first clarify, these numbers that I'm going to give you are in percentage, and secondly, they are by a specific application or by a specific modules. If you roll out these bigger, you'll get more savings in terms of money. And I don't know if I already mentioned, but we license this by CPC. So the bigger the customers they go on these, the bigger savings they will get in terms of money. The worst number that I've seen in percentage is the 47 that I was showing to you in that success story. I've seen also as big as 82%, including all the variables and factors, which that's the cost of the CPUs, the cost of the resources that they are using, and other costs that are not directly impacting here. But that 82% is the best that I've seen.
Yeah, great. So what are some of the mistakes that people make when they implement relocate, when they're trying to concentrate on reducing the mainframe workload and, capture back some capacity maybe? I'm sure there are some common mistakes that a lot of people run into.
I'm going to tell you this is for personal experience. In 2001, I started a project to get off of the mainframe. And we had 2 years to do the project. And the first year, we were just planning and planning and planning. And we were going very deep and detailed on the estimation of the cost savings. And we were not getting anywhere. And we were with some technologies and some, we were analyzing possibilities. With some possibilities, we were getting very aggressive numbers, like 90% cost reductions. With others, we were seeing like only 20%. And, we didn't have like really clear hard numbers, and we were going so deep into the details that we got lost. And then after a year, we decided, let's find without the numbers, what is the possible best technology, get some hard numbers, and start from there. And then 6 months after that, we decided what to do. And 6 months after that, in just 12 months, we were able to turn off that mainframe. So I'd say, don't go too deep on the analysis.
Right.
Okay. Get hard numbers. Make sure that what you have is something that is tangible, that is objective, and start from there.
Right.
And also the tests. Don't go too ambitious. If you really put, too much success criteria on it, and you put your people to do a test that is going to take 10 months, you may be lost by then. Try to do a test, a POC that will not take over 2 months. Less than that, it's perfect.
So I've also heard of people making mistakes around choosing the wrong application. So I guess some of that analysis is necessary to make sure that we get the right application in there. Yeah, because if we get a chatty application that has a lot of back and forth movement of data, obviously that's not going to perform very well when we're trying to concentrate on DB2 or VSAM QSAM files where we've got a lot of sequential processing. So most of the time those aren't batch jobs, so we're pretty safe from making that mistakes. But it's not like you can take any application and apply it there and get those big results that you were talking about, the 82% reduction, that type of thing. So I think that's one of the mistakes. What about the source, the Java source? I know that you mentioned that there's no disruption in the maintenance of the programs in COBOL, but how do we deal with the source in Java? Is that something that we need to be aware of?
Well, to be honest, we do generate Java, and it's stored in the file system of the USS. And some very smart guy who knows Java can eventually go there and touch the Java. We strongly do not recommend to do that, because this code is not meant to be maintainable. The goal is for the impact to the organization on this as low as possible. So we recommend you to keep developing on COBOL and maintain just one single source code.
That's a good point. So I think that I've heard that the Java optimized code, the Java cross-compiled bytecode, is optimized for performance, not necessarily for maintainability. Is that a great way to think about that?
That's exactly right. But the code that we produce as Java for relocate, it's a code that is not meant to be maintainable, but for performance. The code that we produce as Java, which is with renovate, you have options. And there are some parameters that will allow you to either produce for performance or produce for maintainability. And there's something in the middle that is going to depend on what do you want to do with that code. We've seen customers that they just want to run some processes off of the mainframe. We've seen customers that they really want to go off the mainframe, but really keep the same type of operations. But we've seen customers that they really want to convert that into microservices. Our renovate solution has the capacity to give you these flavors and all the in-betweens.
Yeah. Okay. And then there's always a question around the cost difference between the zIIP and the cloud. The question here on the screen is the difference between the zIIP and the cloud. And I think everybody probably understands that. But I think the question is more related to, is there a cost difference? Should you expect more cost savings by utilizing the zIIP or more cost savings by utilizing the cloud?
Yes. There's a difference, and even the zIIP CPUs nowadays, they seem to be a little bit more expensive than the cloud itself. And depending on the kind of deal that you can get with your cloud vendor, this could go like very aggressive and could make you think on really, instead of going to just the zIIPs, go to the cloud, which is, we call this flavor of relocate batch to cloud. and particularly batch to Azure. It's very efficient, and the costs are very, very positively impacted.
Good.
But
and then the last question that we get on there
exactly.
is about data.
Exactly. To the next question, that's what the impact could be. And there are some things that you need to think and make sure. Data gravity, it's key. If you're working in the zIIPs, you're in the same box, right? And we can do some magic to optimize that. If you're working outside of the zIIPs, in the cloud particularly, you need to make sure that you do something to reduce the latency that you will have in the network, even potentially moving the data to a closer environment. Okay. We do control all the readings and writings, as I already mentioned, during the runtime to the BSEM, QSEM sequentials and DB2s. However, controlling that doesn't mean that we can optimize the cable itself, right? So.
Okay. I appreciate you. Thank you, George, for taking us through the material. And
thank you, David.
You all have a great rest of your day.
Thanks, everybody. Bye.